It's a good thing you're.
And normally you gotta get 10 to 20 calories, even though
Well, I want to hear about
I told him, well, literally, you work there and why not? You gotta actually.
You get a lot of, yeah, we had to take that.
Well, that's all I said. My he was in the account. I was like, no, just not there. But I mean, this is there was like 5,000. So, I mean, how much is it all?
Well, you have to have
Anyway, though, was. But the thing is, and then I had to buy the one. Oh, yeah. And I
Set up to go for manufacturing sprockets. I think somebody needs to get by.
It like. Just another minute or so.
Yes, yeah, so all the Exxon scores are public data, they're on the they've got, if I don't work all the way through, like ones down by Tom's Point, that's, yeah, that's true Delta. That core somewhere.
They love them, I bet they already do this.
Yes. Help us in.
I don't know about that. I think I saw more and more people. I just changed the past and it feels like.
This is wait for the 20th.
Yeah, something like that.
Yeah, that's where my.
I'm not sure about.
So this is any semester they have in field coverage. So I went out there, it was out in those little mines.
I don't think about going.
Well, they don't believe.
But also we also have to get.
Yeah, I quit. It was so expensive. I kept asking them, I said, my total is there, insurance taking it out, and it's fine, they were like, no, insurance hasn't taken it out. And the insurance had taken it.
So we
You
can.
know, pay.
Oh, this is your pay, basically.
Yeah.
Does that make sense?
Okay, I've already reached my max.
Oh,
Yeah, it was fine. At the end of this month, before I actually can tell me if I can. But I know, so I'll start.
One of the things, if you remember a while back.
I expected you in some sort of like,
Wheelchair, right?
That was pretty much. He has superpowers now.
Oh, okay. You get bionic.
Yeah.
I'll do it.
Yes.
Yeah.
All right.
Bionic, he can now. Nobody.
Okay, John,
All right.
introduce our distinguished speaker.
Who? Well, thank you all for coming, to the Thesis defense of Braden. Braden has been with us. He came to us from, University of Alaska at not Fairbanks, but at Anchorage, sorry, the real one. And he is native, he is Alaskan. And so he is, matter of fact, actually, I think you knew my former student, Ron, who you worked with him at the DNR in Alaska before you even came here. But anyway, Braden came to us and, like with all of my students, you sort of shop around for projects and say, which one do I want to do? And where is it, how we only kind of go through the ideas and of course, Stan picked Spain and, and Madison came here wanting to do the Palo Duro, and Braden came here and just kind of loved the booklets. He'd spent some time out there and like, well, we can put something together for there. And the Castlegate hadn't had a real good look, even though it's the most viewed, cited set of rocks in the country, probably. Nobody really actually did any serious thing. So in the category of everybody thinks it's done, but it hasn't been done, This will be Braden's thesis. It will be the fluvial architectural analysis and longitudinal variance, the Castlegate Sandstone, Willow Cliffs, Utah. So we'll have a little bit of a session here and Braden will tell you all about his work and then we'll have some questions, kick everybody out and grill him for a little while, make him suffer, and then it'll all be over before you know it. Also want to announce, just to remind everybody, there will be a bull signing. We always have a bull signing when someone finishes. We're shooting for April 25th. We're still fiddling around with the venue and stuff, but obviously everybody here is invited. All right. Thank you. Braden, the floor is yours.
So, like you said, doing a fluvial architectural analysis from the up dip to the down dip reach of the Castlegate, what I like to call Holbrook special. So let's just go ahead and get started. A little bit of executive summary here. So overall, I just want to provide a detailed up dip to down dip story covering the fluvial architecture of the Castlegate Sandstone. There have been some architecture studies, but they either focus on things like sequence boundaries or smaller scale surfaces like bars. But we're going to look at variability in channel style and pattern. We're going to look at patterns of incision and aggradation, as well as what possible drivers of those patterns might be. Okay. Deliverables, we've got 9 orthomosaics, bounding surfaces and borders, as well as their architectural elements. I'm going to provide an idealized longitudinal profile of the system, as well as calculate an estimated backwater length for the system. Okay, starting off with some introduction. You can see Henry over there, looking super sick. Okay, so we're in Book Cliffs, Utah. It's about 200 kilometers of continuous exposure. It's world-class exposure. Everything from the base up to the Castlegate is all Campanian in age. So it's frequently used for education and research in sequence stratigraphy. It's actually one of the birthplaces of modern sequence stratigraphy, and that's where I did my undergrad sequence strat field camp. And transitioning from the severe orogeny in the west is proximal. That's going to be your terrestrial strata, and it transitions to the marine in the east. Tectonic settings, so like I said, severe orogeny, we're in the Cordilleran retro-foreland basin. Sediment was sourced from 3 uplifts, as we can see in that little figure. We've got the Charleston Nilo salient, Canyon Range thrust, and the Pavant thrust, and they each feed 3 of my different proximal outcrops. Possibly we were seeing influence at the beginning of laramide style deformation around this time, though that is still unclear, but it's a possibility. And in the modern, it's just been uplifted pretty flat, so there's been no substantial deformation or faulting from modern uplift, providing us with a great outcrop belt for studies like this. Okay, climate. The Lake Campanian was heavily influenced by monsoonal climate. There's a whole bunch of data supporting that, from carbon-14 data to just physical modeling. We were in a semi-tropical paleolatitude of about 47 degrees north. Mean temperatures range from about 35 degrees Celsius in the summer to 2 to 10 degrees Celsius in the winter, something similar to what we see here in Texas. Average elevation for the Cordilleran Highlands was somewhere around 4,000 meters, so we're pretty high up. Probably be seeing a substantial rain shadow effect there. And so all in all, we have a highly seasonal and very variable precipitation based on seasonality. Okay, regional setting, once again, Lake Campanian. Sediment traveled from severe orogeny in the west to the western interior seaway in the east. And it's a strongly progradation interval, with the Castlegate being the capping unit of the progradational Mesa Verde group. And we have multiple tributary headwaters. The main focus for these guys are going to be the northern and southern transects, which is going to be 2 of my outcrops, Joe's Valley Reservoir and Castlegate type section. As we can see, we have some clustering of our zircon data that shows 2 distinct parents, one from Price Canyon, which is the type section, and one from Straight Canyon, which is going to be Joe's Valley Reservoir. Okay, start with some basic stratigraphy, capping unit of the progradational Mesa Verde group. The base Castlegate is identified conventionally as the base of the amalgamated fluvial sandstones. It overlies the Black Hawk Formation and is eventually transgressed by the bug tongue of the marine Mancos Shale. And the proximal reaches is typically known as a high net to gross, low sinuosity, bedload dominated braided system. And in its distal reaches, it becomes more of a moderate to high sinuosity meandering system with single thread channels. Okay, and now we're going to talk a bit about the sequence stratigraphy. This is the classic interpretation, kind of Barrett Van Wagner, where it came up with the inside valley model was here in the book cliffs and the Castlegate and Desert Member. The Castlegate is interpreted to represent an inside valley fill that was scoured out during low stand and backfilled during the subsequent transgression. And this implies a regionally relative sequence boundary, third order sequence boundary at the base, driven by Eustacy or tectonics. That's another argument. And then the Desert Member and Castlegate, as an implication of this, the Desert Member and Castlegate are unrelated genetically and temporally and are separated by a significant surface that represents a significant amount of time. Moving forward, recent reinterpretations have kind of jumbled this all up and questioned the conventional sequence stratigraphic model as a whole. So recent tracking of shorelines to nearshore muds into the fluvial system have determined that there is no inside valley or basal sequence boundary. It's just a simple facies contact between the underlying Blackhawk Formation and Castlegate. We also see that the fluvial strata of the Castlegate feed the marine shore faces of the Desert Member and Inner Finger. The base Castlegate boundary represents very little to no time, and there is no evidence for any eustatic low stand regionally or within the book cliffs. Okay. Going to move on to our methods. So all of my outcrop locations and their latitude, longitudes are over there if you want to go check them out at some point. I took about 4,000 drone photographs over about 9 locations. Got a few outcrops in some of the locations, but a bunch of drone photos. Threw all those into Agisoft, made 3D models and Orca mosaics. After that, once again, Holbrook special. I applied orders. I traced out the bounding surfaces and applied the orders. Got some measured sections at each location. Then I calculated backwater length using these equations down here. Got an equation for slope, an equation for backwater length. And to make those calculations, needed to collect grain size, channel depth. Channel depth was typically in this study just a overall looking at bar forms with partial or full rollover. Okay, so now we're going to move on to results and interpretation to show you guys a bunch of pretty pictures. Okay, so for each outcrop, first slide is just going to be this, the photo or the mosaic, the bounding surfaces, and then the bounding surfaces with architectural elements overlaying. So here at Salina Canyon, the only thing that was very clear on the outcrop was 6-order channel belt scours. But as you're going to notice, we've got lower flow channel sheets, upper flow channel sheets, and one nice lens of overbank deposits. This outcrop in total is about 53 meters thick. It's dominated by channel fill elements, but we do see an up section increase in upper flow regime bed forms. So there are locally thin overbank splays interbedded in between your channel belt sheets. Our lower channel fill is dominated by upper medium to coarse trough cross laminated sandstones, and the upper channel fill is dominated by upper flow regime deposits, coarse to pebbly sands, and we see chutes and pools, anti-dunes, see planar bedding and transitional bed forms, as well as localized cross laminations. So here's an example of one of our upper flow regime sheets. As you can see, we've got a highly erosive undulatory basal scour. And that guy's going to be infilled with some unstable anti-dunes, pretty similar to this idealized model above. An up section in each one of these individual sheets, we see a decrease in grain size up, as well as a reduction in flow regime in the bed forms. As you can see in the sheet above, we start at upper plane beds and transition up into normal flow trough cross laminations. So that's indicative that these are filled during waning flow, and they represent large flood events, scour and fill. Okay, Joe's Valley Reservoir, the next guy here, we actually see some 7th order valley fill elements, which is going to be pretty interesting moving forward. So this outcrop is 68 meters thick. We're dominated once again by a channel fill and downstream creating bar forms. There's 2 intervals, and these are separated by the first occurrence of a 7th order valley surface. The lower interval is just going to be amalgamated channel belt deposits with very little overbank, bars and channel fill, trough cross laminated sands. The average bar height in this lower interval is about 3.1 meters. Moving to the upper interval, you see small valley scale incisions of up to about 12 meters in thickness. There are substantial overbank deposits that are preferentially preserved on valley terraces. So bar and channel fills are very similar to the lower interval, with the exception of localized conglomeratic channel fill in bar forms. An average bar height here has increased substantially to 4.5 meters. Okay, here's an example of one of our gravel bars. As you can see, they're pretty coarse. We've got gravels up to 10 centimeters in diameter. This guy's about 4.1 meters thick. But so there are some flood-induced features that we see here as well. Just climate-driven stuff, such as the large valley scale scours. Our localized conglomerate intervals are likely indicative of floods bringing in coarse grains. Increased flow depth overall from the lower interval, as well as the prevalence of convoluted bedding in the suburb section that's indicative of rapid deposition. Okay, moving on to the Castlegate type section, the Castlegate. So very similar to Joe's Valley, except no valleys. This guy is about 75 meters thick. Once again, it's dominated by channel fill and downstream creating bar forms. We're still braided. Medium trough cross-laminated sandstone is infilling our bars and our channels. Our highest order surfaces are channel belt bounding surfaces, but once again, we do see two distinct intervals here. The lower interval, amalgamated channel belt deposits with an average bar height of about 3 meters, very similar to what we saw at Joe's Valley Reservoir. But moving up, we see channel belt deposits with increased spacing and increased overbank preservation with an increased average bar height of 4.41 meters, which once again is indicative of an increase in discharge up sections similar to Joe's Valley Reservoir, except we just don't get any of the valleys forming here. Okay, moving on to Sunnyside Canyon. All right, we're moving a little more east, getting a little more distal. This guy's 55 meters thick. It is dominated by channel fill and downstream creek bar forms. Once again, we're still in the braided system. The highest order surface here, once again, is channel belt bounding surface. So two distinct intervals, much like the rest of the proximal outcrops. The lower interval is amalgamated channel belt deposits with an average bar height of just over 5 meters. And this is just representative of the downstream evolution of the fluvial system as our tributaries kind of lead into a larger system down dip, showing increased channel depth. The upper interval, though, is just ribbony sands and overbanked muds. We see these very small scale channels of 1, maybe 2 meters thick and a lot of overbank deposits. In my interpretation for this, that we're likely just off axis to our main trunk channels at this point, where we are no longer getting our trunk channel deposits preserved here. We're off axis where we just got some smaller channels cutting through tributary to the main. Okay, Woodside Canyon. Just take note here that we've got multiple pretty large incisions from 12 to 20 meters. These valleys are vertically stacked up section. And so this guy's about 45 to 50 meters thick. Once again, we're dominated by channel fill and downstream creating bar forms. We are still typically braided. Average bar thickness here is 5.5 meters. So once again, an increase from the last outcrop. Our 12 to 20 meter deep valley incisions are stacked vertically up section. They have varying fill. We have some that have multi-story channel fill. We've got this guy down here in the purple, which is filled with the lacustrine delta. And up at the top, we've got one that is just mud filled. So these valley fills, especially the lacustrine valley fills and the mud filled valleys, just interpreting an up dip channel, large scale channel avulsion that leaves an abandoned valley that can then be infilled with lacustrine deposits. And one thing I will note is that underlying the Castlegate, the base Castlegate here is very cryptic. We see our mudstone rich interval transitioning laterally into an amalgamated sand. So it just means that, is this truly a sequence boundary? I don't know. You can see it moving up and down section as you move along the outcrop out here. Okay, moving on to Crescent Canyon. Let's just take a second to admire that beautiful point bar up there. Okay, so that guy is about 20 meters thick. And here we're sitting above what is conventionally the base Castlegate is this base Castlegate toll marker. Okay, we're about 30 meters thick here. We've got 2 intervals, each bound by 6-order channel belt surfaces. So we've got large trunk channel deposits here, and it's incised by this heterolithic channel fill. And laterally to it, we've got this large point bar complex, just showing some south-southwest migration. And once again, this is indicative of, a single thread trunk channel, and it is within backwater length. So at about 19 meters with a slope of 0.0002 meters per kilometer, you have to be about 120 kilometers away from the shoreline for it to be outside of backwater reach, and there are no shorelines that far away, so we must be. Okay, and capping this, we have an amalgamated single-story trough cross-laminated channel fill. It is very homogeneous, so any bounding surfaces internal to that are very cryptic, but it does not show any evidence of marine or tidal influence, and it is the most distal outcrop that shows any fluvial strata without marine or tidal influence. Okay, so this outcrop becomes more proximal up from our nearshore trunk channels up into our non-marine influence channels near the top. Okay. West Blaze Canyon here, right? So West Blaze Canyon transitions laterally from about a 4-meter thick fluvial sheet with localized valley incisions of up to 16 meters, such as the one used in this study. The channels incise into the underlying time equivalent short face deposits. Valley fills show tidal influence, mouth bars, heterolithic lateral accretion sets, and previous studies that got measured section at this location. Not quite sure how they did it. It's on a cliff face about 1,000 meters up. But they show plentiful evidence of transgressive shell lags in some of these channel fills, as well as brackish water burrows like Trigoleides. So previous studies have determined that these valleys are autogenic in nature, induced by just channel surface drawdown during floods in the backwater reach. The nested valley up top is interpreted as a younger channel incising over the top as the system prograded over it. Once again, channel belt returning to this area. But it still shows significant tidal influence, but it has a sandier fill. Okay, Thompson Canyon. This one's a pretty cool one. So we're going to start off. Thompson Canyon has been interpreted as prograding estuarine deltaics. And I'm just going to kind of walk you through each little piece and where we are in the system. I've got a depositional model here. Everything is labeled A through E as they are on the depositional model. And starting at A and B, A is going to be our medial delta front. We're going to be sitting in some of our cliniforms there building out. We can see that there's climbing ripples and Trigoleides trace fossils there indicative of a brackish environment. Also our mouth bar complex there, base of that shows plentiful Trigoleides burrowing, and it's typically massive to trough cross laminated. Moving forward, we see our subaqueous distributary channels on our delta top. This is going to be proximal delta front. Okay, so we're just moving up the system. Here we see a bar with climbing ripples, and there are localized trace fossils in there as well, marine traces. And moving on to our subaerial distributary channel up here, D, that is going to be just feeding the delta. Here there are no trace fossils, but we do see trough, we transitions from trough cross-bedded to rippled channel fill, likely indicative of just some tidal influence into that channel. And then finally, capping the interval, we have our tidal sand and mud flats, where we see some localized scalithos furrows, but it's overall just ribbony, interbedded muds and sands with marine influence and plentiful carbonaceous matter. So overall, we've just moved from our medial delta front and transitioning up into our delta plane. So just overall, just a progradational system in a overall brackish environment. Okay, and finally, our most distal outcrop is going to be Sulphur Canyon. By here, we are basically fully marine at this point. So this is interpreted as just a distal shallow marine delta. We start at the base with our delta front here in green. We've got some terminal distributary channels in there. But as you can see, it's coarsening up section. You start really muddy at the base and it gets coarser up section. We see areniclites and diplocriterion traces in locally in some of these tabular sands. These tabular sands or the areniclites and diplocriterion are indicative of relatively shallow marine but lower energy environment. And then, so once again, over there you can see Henry with those tabular laminae of alternating sands and carbonaceous muds. And moving up to our delta top, we've got mouth bars and tidal sand flats, as well as our subaqueous tidal channels here. Our tidal channels typically show bidirectional ripples. We see plentiful ophiomorpha traces. We see a lot of bivalve imprints and skelethos. This is indicative of a higher energy environment. This is going to be our delta top as the delta progrades out. Okay, now we're going to discuss backwater length. So all this data was collected at Woodside Canyon, got bankable depth from bar forms, got D50 from just above the base of some of these trunk channels that we measured. And from there, we were able to calculate slope, came out to 0.000199 meters per kilometer, which is consistent with everyone else who has done studies on the slope of this system, puts it at 0.0002. So we're just sitting right in that range. And the backwater length that I calculated came out to about 24 kilometers, which aligns with previous studies who have calculated it between 20 and 30 kilometers. And basing this on Woodside, we're likely starting off in parasequence D6. These parasequences are from Pattison, who created the new depositional model. So we are likely within parasequence D6, and Woodside would lie within the range of Nick point migration of dip between parasequences D6 to D9 with a conservative backwater estimate of about 20 kilometers, and up until parasequence C4, we take the higher estimate of about 30 kilometers. Okay, let's move on to our discussion. All right, so I'm going to go ahead and just put some context to the location of these outcrops real quick. So up at the top, we've got our three proximal outcrops, Salina, Joe's Valley, and the Castlegate type section, each fed by their different tectonic uplifts. And moving west, we go see Sunnyside, Woodside, and then we've got a pretty tight little grouping there of Crescent, West Blaze Canyon, and Thompson Canyon. And then way up to the northeast, we see Sulphur Canyon finally. So here's just a little schematic of the transects, the different transects of the Castlegate system and where they might feed. So Salina Canyon prognostic study shows that it doesn't really connect to the overall system within the outcrop belt, probably headed somewhere south. But Joe's Valley Reservoir definitely heads to Woodside Canyon. Type section definitely heads to Sunnyside Canyon. But the question is, where do these guys connect? And that is something that further prognostic study is going to need. But there is evidence of sediment mixing from the northern and southern transects, so about 10 kilometers east of Woodside Canyon. Okay, trackable surfaces. Through this study, it's been deemed that surfaces, sequence stratigraphic surfaces, cannot be tracked throughout the entire Castlegate system. Okay, so distal surfaces are going to terminate near Woodside Canyon, as that is the up-dip reach of Nick point influence. So the up-dip reach of what you might expect to see via any eustatic changes. Subsidence rates reduce substantially down dip, so any surfaces created by tectonic subsidence up dip, once again, should terminate by Woodside Canyon, because that's where about you lose all of your basinal subsidence. Outcrops also, it's not likely that they represent one continuous fluvial system. So as we can see from Joe's Valley to the type section, they have very different responses and probably would create different surfaces at different times. So being able to expect to laterally track those surfaces even might be difficult. They have very different architectures. Okay. Modern studies of the Ganges-Brahmaputra River show a very similar thing, where in the distal delta front, you're responding to eustatic sea level, but once you get up dip, your transects are responding to tectonic subsidence and sediment supply. and they've age dated sediment and deemed that there are no continuous trackable surfaces between the two. Once again, they also have deemed that along the different transects, you get very different responses based on tectonics and sediment supply within the different transects, and the different transects of the Ganges, Brahmaputra show very different architectures as well, which is similar to what we see here in the Castlegate. I will note that here at the base of the Castlegate, where the Castlegate and Black Hawk contact comes into play, it is a very cryptic boundary there, and you can see it interfingering with the underlying mudstone-rich Black Hawk strata. So it's very unlikely that that would be a true sequence boundary, as it's not really representative of time surface, or it's not even continuously trackable throughout the system. Okay, now let's take a moment to discuss the valleys at Woodside Canyon. There's multiple ways that you might induce valleys, one of which is Eustace, but in this instance with a 15-meter or a 20-meter valley and about 5-meter average channel depth, you need to induce sea level drop of about 15 meters. Given the shelf slope calculated herein and used in general in the book Cliffs, that would induce a 76-kilometer progradation of your shorelines, as well as a 76-kilometer inside valley system, neither of which are expressed in the down dip marine strata. Tectonics is another option, but since these valleys are stacked vertically up section, we need to induce multiple tectonic events that would cause incision and then subsequent filling, which is unlikely on this time scale. Also unlikely because the scours are not regional. They're really only observed locally here at Woodside Canyon. They're not clustered on an individual surface. They're stacked up section. So it's very unlikely that tectonics was the driver here. One idea that I had was that it was possibly just due to the river confluence, because in the modern river confluence can show scour depths of 4 to 5 times the average channel depth during seasonal monsoons, which was represented by the localized nature of these incisions, because those modern confluence scours only stretch for about 2 kilometers. But if it was a confluence scour, you would expect to have some channel form like bar forms that were scaled to the channel depth, since it is an individual channel, which there are not. So that brings question to the hypothesis, makes it unlikely. So conclusions here. It's a climate-driven buffer valley. So there's no evidence for tectonic or sea level drop. What would happen is, as upsection in the proximal outcrops, we saw an increase in discharge overall within the system. You increase that discharge, it's going to cause a drawdown of the river profile, causing incision and subsequent filling. Okay, and Holbrook 2006 discussed buffer valleys and the fact that they taper from up dip multi-story to a single story incision down dip. Evidence of confluence of the northern and southern transects has been confirmed by provenance and grain size data just about 10 kilometers east. No one's done the study at Woodside Canyon yet to prove that it does have a mixing of the two transects, but I think it is likely, as it happens 10 kilometers east and by Sunnyside there's no influence, so it's somewhere between the two in which Woodside lies. So it's a little bit more work to be done to prove that fully, but the strongest option. Okay, and then climate. There was likely an increase in climate or flood frequency and strength upsection within the Castlegate through time. Evidence for climbing or for climate are pretty prevalent throughout the outcrops, and it's likely a large driving factor of the fluvial architecture of the Castlegate, but it's typically been overlooked as one of the drivers. It's always tectonics or eustatic storage channel belt erosion. So evidence, though, we see is upsection increase in upper flow regime deposits in Salina Canyon indicative of large floods. See an increase in channel depth at Joe's Valley and the Castlegate type section. We see valley scale scours at Joe's Valley and Woodside Canyon, likely driven by climate. We see prevalence of convoluted bedding increasing upsection in all of our proximal and medial outcrops. An increase in coaly and carbonaceous deposits upsection in some of the outcrops. Lacustrine deposits observed at Woodside Canyon are indicative of a relatively wet environment. And then even in the distal, we see our flood-induced backwater scours. Okay, so pretty prevalent evidence for flooding. Okay, moving on to conclusions. All right. The Castlegate sandstone represents an increasingly flashy and stronger discharge regime of section. So an increase in monsoon strength throughout the Campanian and the deposition of the Castlegate. Outcrops at Salina Canyon, Joe's Valley, and the type section are representative of different transects. They show very different architectures, and these architectures are based on aggradation, based on slope, discharge, and subsidence rates of the system, which can be different on the different transects based on their different problems. Okay, the Castlegate sandstone from proximal outcrops to Woodside is responding to sediment supply, subsidence rates, and from Woodside to the east is responding to eustatic sea level rise. And these two surfaces created by the marine and created by proximal subsidence should not be expected to be tracked into one continuous surface, as they're two separate systems. Okay, valleys at Woodside are on the margin for the up-dip range of midpoint migration, but they do not correlate to any significant eustatic sea level drop. So they were not induced by sea level. Once again, large cut and valley or cut and fill episodes, our valleys at Woodside are caused by an increase in discharge, a shift in climate that causes an up-dip buffer valley profile. They are not seen anywhere else in the study. Deposits at Thompson Canyon are likely representative of a true inside valley fill cut during the subsequent sea level low, and then backfilled with progradational deltaics on the next sea level rise. More evidence would be needed to determine this for certain, as the valley scour at the base is cryptic due to it mostly being covered. Okay, and that is very different contrast to the climate-driven valley seen at Woodside. All right, Castlegate sandstone transitions from high accommodation, braided fluvial, and the proximal reaches to a low accommodation, meandering to shore face and sizing tidal fluvial system in the distal reaches, and there is a substantial increase in overall channel depth as you move down depositional depth. Okay, recommendations, just a few things, we're almost done. Up-section provenance study at Woodside Canyon to determine for certain whether the confluence is up-dip from these two. In-depth architectural analysis of more Castlegate outcrops, because like I said, 200 kilometers continuous, there's still plenty more outcrop to do. Fill in the gap of outcrop from the medial to distal interval, because there was a little gap that I left there. An in-depth study at Woodside Canyon would be really cool, because there's a lot going on there, and there's a lot that I couldn't get to. Further analysis of more continuous outcrops near the Castlegate type section. I chose the type section, but there are more continuous outcrops just around the corner. Are there valley scale scours like we see at Joe's Valley, or is it truly aggradational like I observed? That's another question. And then if it's possible, oxygen 18 analysis of the channel from proximal to distal, and see how much of the water was actually sourced from the highlands versus how much of it was dumped down in the medial region, and see how that might actually affect your architecture within the system as well. Okay, I would like to thank Dr. Holbrook for letting me spend 2 months out here in the Blue Cliffs. It was awesome. Thanks Busby and Bo for being on my committee, even on kind of short notice. Appreciate you guys. Thank you to my field assistants, Henry, Sam Knox, and Peyton, who couldn't make it today, unfortunately. Thanks to Dr. William Little and Dr. Jennifer Ashoff for giving me some insight on possible outcrops I might want to take a look at. And thanks to everyone else for just, being around, watching me struggle. Right. So, questions?
Questions?
Yes.
Probably a basic question for you, but I don't know what backwater length is.
Okay, so
Why do you measure it and what does it tell you?
So backwater length is basically, so the sea level surface, right? And a river cuts down below, like the base of the river channel is going to be below sea level, right? Because the sea level will be the river surface. That is based on slope, right? And the river depth is where that sea level is going to intersect your channel base, right? So one thing that you can get from that is like the backwater induced scour, right? So during floods, You're gonna get drawdown of that water surface to sea level further up within that backwater reach. It's gonna increase your scour depth and stuff. And really, it's gonna be able to just tell you how close you are to the ocean and how that's gonna affect your architectures.
Got it, thanks.
Yeah, no worries.
More questions? Well, in the interest of time.
Okay.
All right, if I could ask everybody to head out, the committee to stay, please. Right, Dan.
See you, Henry.
Thank you, guys.
All right, okay.